it mean to factor a polynomial? What does it mean to solve a quadratic by factoring? Let's get into it. Hi, I'm Sarah. I've been a STEM and math and science teacher for 20 years, and I'm here to make math and science engaging and fun and not so scary for everyone involved. Check out our Patreon if you need live tutoring, one-on-one tutoring. So factoring a trinomial. If you're not doing this yet, just buckle up because it's actually really fun to do. And you might surprise yourself by like totally getting it. You might not, but that's okay. It's still somewhere in your brain. That's fine. So what we're going to look for is with this number. So with a quadratic, it means that it follows this sort of pattern, right? You have an x, you have a variable squared, then you have a variable by itself, and then you have a number. Sometimes you don't have the variable by itself. Sometimes you don't have the number, but usually you're looking at these, right? So when we're looking at these, what I'm going to look for is I am looking for two numbers that multiply to -5. So they multiply to equal -5, but also add to -4. So you have to find things that add to -4 and multiply to -5. So if we think about the factors, right? If we think about the factors of 5, makes it really easy because it's 5 and 1. Now, if we've got this negative floating around here, right? If this is negative, then they need to be different signs, right? Our two factors. Okay, so in this case, we're going to have -5 and +1. Why? Well, because -5 and +1 do multiply to -5, but they also add to -4. Okay, so there's lots of little things where you kind of go like, oh, well, if this sign is here, then it's bigger. But I just kind of go through and logically reason it out. But I know some people really like those hard and fast rules. Whatever floats your boat is totally fine, right? But our two factors are going to be -5 and +1. So we've got -5 and +1. Those are what multiply to -5 and add to -4. So now I can rewrite this as two factors. So to factor something means that you're writing it as a multiplication problem. So we've got x minus 5 times x plus 1. And those are still going to be equals 0. Okay. Now, if we were to go through and FOIL this, right? X times x is x squared. X times 1 is x. Minus 5x gives me -4x. And then -5 times 1 gives me -5. Okay, so now we've got x minus 5 times x plus 1. So we've rewritten this in a way that now we can solve this. Okay, because if you've got two things or however many things, right? If you have like 1 million numbers and you multiply them all together and 0 is the answer, that means that one of them had to be 0, at least one of them, right? So in this case, one of these, or well, to multiply, if you multiply these together and you get 0, then one of these, either x minus 5 or x plus 1, must equal 0 to get you to that 0 point. If we go back to the graph, right? Remember, this is just sort of a basic quadratic graph. I'm not saying this is this graph. Don't come at me with that. We know that there are going to be these, we might have these two different values. Sometimes you have no real numbers, but that's okay. We'll get into imaginary numbers another time. Okay, so now we know that either maybe it's x minus 5 that equals 0, right? When x minus 5 equals 0, then it's like on the x-axis, right? Or yeah, on the x-axis. Maybe it's the x plus 1 would be 0, right? At x minus 5, it's 0, and at x plus 1, it's 0. So if I subtract these and I just solve these, I have x equals -1 and x equals +5. So what that means is that when x is 5 and when x is -1, that is where it hits that x-axis. So this is actually a little bit more shifted over if we look at the graph. So we've got x equals 5 there and -1. Okay, so this is going to be somewhere like this, right? So then we've got our two zeros, which are at x equals 5 and x equals -1. So the domain, with the domain and the range of this, so our x values would be all real numbers, right? But our y values, I didn't find what the vertex was. The vertex is this point where it like turns. So in a minute, I'll show you guys how to do the vertex and the domain and the range. So y equals x squared minus 4x minus 5. Execute. No, stop. Ah! There we go. All right, so the vertex of this is 2, -9. So the vertex, wow, I was way off on that. So it's 2, 3, 6, 9. So the vertex of this one is 2, -9. Okay, so the vertex of a quadratic is where it kind of like curves, is that lowest point or the highest point, right? So if it opens up, which is when this is a positive number, if it opens up, it's got a minimum, right? Because that's the bottom, the minimum value. And then if it opens down, right, that would mean that this is a negative. So then that would be the maximum value that you could have. Okay, so my vertex is 2, -9. And then I've got, I like using the table. So I've got 2, -9, and then I've got 4, -5, and 3, -8. 3, -8. 3, 6, 8. There we go. All right, so couple parts. Oh, and we already figured out our zeros, right? 5 and -1. Really cool thing about quadratics is that they're mirror images. They're symmetrical. So the axis of symmetry, which would be like the folding line over it, it passes through the vertex. So this is my axis of symmetry. Okay, and I like to show it as a dotted line. So yeah, my kids have a final over this next week. Wonder if any of them are here. Okay, so with the axis of symmetry, what's really cool about this is that all of the points are mirrored. So like this one here is 1 away from the axis of symmetry. So over here, there's 1 in the same spot. Over here is 2 away, 2 away. So there's 3 away. So then here, I can do that. And all of your parabolas end up looking a little bit more like V's than U's, but that's okay. So the reason we get these like two sides of this is because of that exponent there, right? That we've got this positive, basically it takes like your negative x value and your positive x value. It sort of flips it, right? If you just kind of do like the negatives, or sorry, if you do like a negative squared, you get the positive. If you do the positive value, right? It kind of like plays around with it. But once you have those exponents in there, means it's no longer a linear equation. And so you've got this, something's going to be curved. So here, my minimum value, my y values they're going to be anything that's greater than or equal to -9. So my y is going to be greater than or equal to 9. That is my whole range of values for my y. -9, I forgot the negative sign there. So -9 is less than or equal to y because it's going to go all the way up here, but it's not going to go any further past this. And then the x values are going to be, so my x values can be all real numbers. They can be any number because this is going to keep going forever and ever and ever. And eventually it's going to be all gone. Not all gone, but you're not going to see it. That's mathed up.